Good morning. All right. We're going to keep chipping away at this. Good morning. We're going to keep chipping away at this. Making a little bit of progress. Let me see. My watch is bugging me. Let's move that. Um, let's see. Should we work on adding some unit tests or a little bit more tests plus functionality? Hmm. Last time we did look at the test coverage reports. Mostly edge cases remain. We have fairly good test coverage of these requests for the both the server and the client. What we're missing is an implementation of stream database updates. Music kind of came to a little crescendo right there, just the right time. That's fun. It's not very relaxing music though. All right, here we go. It's kind of upbeat. I think we should start on this piece here. Most of the tests on the client stop at this point. They don't actually test this functionality. We could start there. And let me. I would be over here in this section. Or we could start on it here. Which direction? I'm leaning towards implementing it on the client. This should be a shorter lift. This one here, we actually have to be able to pull data from here and incoming data at the same time. So we need both. Basically, we're going to have to pull data from storage repeatedly until it's close enough to the stream to start sending it. Maybe we also have some sort of temporary buffer with just X amount of data dedicated to holding mutation state in memory so we can stream the last hour's worth of data. That could get very large very quickly. 10 minutes worth? Or maybe it's just a certain amount of data, a gig of data, right? Most of what this machine is going to be doing down here is going to be just passing bytes back through it. So if we had a buffer, like a gig of RAM, that seems like it would work. Just a giant circular buffer. Yeah. It should have some decent overlap with this. Okay. Let's do the client. Client. Oopsie. Thank you for the follow. I appreciate it. And welcome. Now, when we're implementing the client, we also have to implement our test server, which is a bit different from the actual server. It's a bit of a shell, and we only want enough of it to implement the client or to test the client. Let's grab some test bits here. Let's rename this. I don't really care if they're in or out of sync. In sync would probably be easier, but it's unlikely to happen. I think the common case oh, excuse me. I think the common case is going to be that the test server starts, sorry, the client machine starts up the reader. And then after it syncs its out of state portion, tests that everything else is good, that the stream works. We could try here, or we could implement a test down here. Oh, a little EQ for the voice is a genius idea. Well, thank you. I used to have my face down there, a little headshot, picture of me speaking. But I mean, quite frankly, I don't really, I don't really care for that. So thank you. Oh, Hold on just a minute. 30 seconds. Be right. All right. I say we have two different tests. We sync an out of state database, out of sync database, and an in sync database just to make sure we get all the coverage. Now, an in sync database would be here. No. Well, thank you. Yeah, occasionally I have people that join the channel just to fall asleep, listening to me ramble on about Rust programming, and they'll just relax and fall asleep. I should just have like a book reading time. That'd be funny. I don't know what we would read though. The Rust programming language. Right. I wonder, can we use something like this as a fixture? Voice made for radio. Thank you, little boo. Hmm. Read the whole thing, the whole Rust programming language with the whole appendix. Oh man, that put my wife to sleep. Basically, I want two versions, two fixtures. Mm. We want, let's see, basically everything up to this point. Oh, goodness, what do we call this? This is test context. I think this function name is wrong. We are sending the database. Got it. So we call this fetch database event, and then we send the database. Mm. Rename this to send database. Stream is the piece I don't like. So what are we doing? We are reading the database, chunking it by pages, and whoop. Oh, where'd it go? Here it is. And then we stream it. Well, we send it over a stream. I think send is more appropriate. Chunk and send server database. Hmm. What does that look like? Chunk and send database to stream. Hmm. All right, I could get behind that. Well, thank you, Flipsy. Thanks for hanging out a bit. Yeah. Happy New Year. Take care, Flip. Async function. Let's set this up as test context with downloaded database. It's essentially from here down. Spell Cruncher. Well, thank you. Thank you for subbing. You are supporting my coffee and tea habit. Thank you. Oh, and the music. Let's see. So if we have that, we could, oh goodness, we could use it here and then just end this test early. What would that look like? Let's just, oh, the game. So we were talking about This game that wasn't performing well stores information as SQLite. But it's that game has all of its it saves its files as SQLite databases, but .sav files. Oh, that's funny. Oh, and this here, it essentially awaits the future for you. So you can have fixtures, and the fixtures can be async. But if they're async, you either have to await them, which is one more line here, or you can annotate them and it will await them for you. Oh, Spell Cruncher, that's great. I think that's a great, great way to save your data. Just dump it as SQLite. Hmm. All right. So let's say we had this test. We wanted to change this. Oops. Test context with downloaded database. Let's try this up. We end up renaming this is already done for us. Interesting. So at this point, we just want these lines. Okay. Oh, at the end of the file. I forgot to return it. Ooh, but this has to live. If this drops, what happens? No, we need that in the test. We have to return both. Was it join handle, sync manager, something? This would be a Tokyo join handle. All right. Test connection manager. Nothing's in scope. All right. And the type has to be right here. Let's see. Type. What do we call this tuple? Test context with Sync Manager. I forgot the test context. Yep, should be a WAL file. Yeah. It saves the game. Oh, that's pretty cool. That actually is a great idea. Because if somebody turns the power off, kills the game, it crashes. That's a recoverable file format. You may have lost a little bit of data. Right? Maybe your entire transaction didn't save. But it wouldn't have corrupted everything you had before that. I like that idea. And if they want to obfuscate it, I'm sure they could. They could do that. If I was writing a game and I cared about people mucking about with the save file format, and the save file format was SQLite, I would probably just have a VFS that changes the format on disk. And the VFS would be part of the game itself, the game engine. It'll say, hey, here you go, here's your VFS. And then people wouldn't know how or where to get it. Hey, Sarcastic Dante, how are you? All right. So we have that. This here is now test context with Sync Manager. And I forgot that again. Okay. I want to see this actually pass on the right. Right? Going to take that, drop that here, get rid of our previous stub, rename it, test database. There we go. So at this point, we can get an event. What do we do with the different types? So we're expecting a server event, which is good. We assert that it's a certain type. Return that. What's the event request? Stream database request. That's the information that we received as part of the request. We could validate that. I wonder what's in that. Might as well. Let's pass that back with the stream. Mm, I think that's right. Okay. Oh, that's event request. Just going to look over this, see if there's any location that actually uses the return value. Why am I not seeing it here? Oh, we do. And we just drop it. Okay. Is that needed? The drop? Sometimes it is. Sometimes the client is actually in a very specific state where it actually needs, yeah, it needs the other end to be dropped, which is what we were doing without binding this to a variable. Let's just not bind it to a variable. It should do the same thing. I'm going to pour some more tea. Man, I'm just a little off today. I don't know, just... Okay, that's an improvement. Let's go back. Yep, nothing reserves that. Let's do that here. Let the request, they will equal that. Then later we have to drop the stream in order to shut down. Hmm. What do we want to assert here? Our shard should be test. The name. Oh, I don't know what the name is. Is it happy? It is. That should be. Hmm. Oh. Oh, Spell Cruncher. Let's see. He said. So maybe the game file acts as a read-only database, while the journal and wall, the write-ahead log, act as a way to handle updates or changes. That's very much in line with what SQLite does. The database, the .db file, or whatever variant of extension it's using, .save, is the actual database. When the game shuts down, or basically when all clients of SQLite disconnect from a wall or from a database that has a journal, like a .wall file, the last one disconnecting is supposed to transfer all of the information that's inside of the wall back into the database itself. I'm surprised that it's not doing that. And that's actually, you were saying that it's slow. It could be that the wall file isn't being um, what do they call it? Checkpointed back into the main database. That would slow it down eventually. Let's see. Let's change this to 0 and you know the default behavior of SQLite, just opening it with the console, and that is dot opening a SQLite file and whatnot, is supposed to dot quit is supposed to compact the database. Interesting. Or close the game, just open it and make sure everything's getting compacted from the wall log. Just going into it and exiting it should do it if it's not doing it already. When you leave the game, does the wall log persist? Because it sounds like, well, I'm curious, just curious. Oops. Stream database updates. And to parse a 4 gigabyte XML file to find that. Wow. Just wow. Okay. So we should be able to validate. Oh, some of, yeah. Okay. This is the actual code. Ooh. Okay. One more. Goodness. All right. Back to where we were. This should have failed. And before we get too far, I want to see if that fixture can be used anywhere else. Create server DB. I think most are fine the way they are. Okay, let's leave it. There we go. Mutate server DB. Where does that get used? Okay. In one place. It gets used in one place. We want something like this, but we're not sending. Pages are being sent in a slightly different way. Yep, don't want that. Basically, I want to do this after all this other work has been done. There's a difference between fetch database response. Come back here. Fetch database response has information about a page. However, when you're streaming information, you need that info, the page number, the page data, the page checksum, number data checksum, and the DB checksum at that point in time. So what we need is just to return that information, all 4 pieces. All 4 pieces is a database page, one of those. We can drop it down. Let's see. We can convert the type. Server DB checksums, hash DBs. I'm looking for the checksum of the entire database. Here it is. That, it's a ref to the DB itself. That's a poor name. That's a little better. Because at that point, we could have what? Server, let's see, DB checksum. Yeah. It's U32. Updated pages. We have to change the type on that. Because of our response type, these are now database pages. All right. So at this point, we have a DB page, but it's the wrong type for this kind of stream. This one's a fetch database response. We could convert it right here, or we could go into data proto, lib. We have all of these pieces here. The generated content gets pulled in. Impl from database page for database. Oh goodness, what was it? Was it a fetch database response? Yes. Hmm. Why won't you do that for me? It's chewing on something. All of my requests are timing out. There we go. Welcome back, computer. Page number. Okay. Lovely. And then down here, can I find stream sender? Because it is stream. Expected response, unbound receiver stream. Ah, okay. This is a little bit different than I was expecting. Okay, we can do that. Hmm. So after we validate the request, we need to respond to the request with something that has a stream in it. What is a tonic response? We have to know that? Okay. Is it Tokyo wrappers? Hmm. Tokyo wrapper. This is a unbounded receiver stream. Oh, it's Tokyo stream. There it is. Okay. So we send that back. Then we have our other side. Now, how do we know that everything is correct at the very end? We check that all of the database pages are identical. So at one point, we mutate the server database. Then we check for any changed pages, send them on the stream, and then they should both be identical at the end. But alas, they are not. Oh, they're not the same for a good reason. Our database's checksum is not correct. I think that we wrote the code for the client to download the stream and apply it to the database, but we've just never written a test for it. And it worked. Okay, well. Spell Cruncher. Let's see. You're still trying to understand why it stores these save files into the de facto folder. That is not a SQLite thing. Yep. There's no special meaning in the SQLite universe. Nope. That's strange. I have no idea. Okay. Now, this should have tested quite a bit of code. We are going to run. Let's see where. Oh, here we go. Let's run the clean first. We want the code coverage for data plane. And this will take it a minute. And then we can see if that has now covered the everything we want to at the moment. There's going to be a number of error cases that we do not cover. And that's okay. That's okay at the moment. I want enough test coverage that we know when something breaks, but it doesn't have to be so much test coverage that when we break something on purpose because we are roughing this out, we don't want so much that it is a hindrance into our velocity. All right, let's open this. Where's Firefox? Come to me, Firefox. All right. So most of what we're looking for here is, oh, interesting. Some hit 100. It's our little into that we wrote. Okay. DB checksum lib is now at 100. Oh, that's the same. Oh, data proto. And this just checksum is called. And our test code has 100% test coverage. Jumping through here. Oh, some red zeros. Convert not found. This is called from some of the error cases. Okay, I'm going to see a number of those. Eventually, I'll come back and patch this in, right? In the finishing phase. Why do I still have this big block here? Oh, this was the old code. I replaced that with this. Yeah, okay, I should delete that. It's working. That's line 274. Good bytecode. Much better. Okay. Yep, error case. Attempt database download. Error case. Okay. Oh, we can get rid of more for attempt in O.2. This now works. Fetch database info. Good. Just error bits. What is this one? Oh, check some mismatch. Okay. That'll probably get covered once we start testing the error cases. So far, so good. Okay. Well, if anything, it's gone up from last time, which is awesome. Oh, we can delete this section too. Test database download. This one. We split that up. There is a similar version that I'm tempted to implement. I don't know that it matters though. Well, I'll probably get to it if it's needed during the finishing pass. Good. Hmm. I wonder how many pages we expect to be here. Changed server pages dot length. And I'm just going to say 5. It's not going to be 5. Just want one more check. The big check is that the databases are identical. But I don't want them to be sending all of the pages in the database. Yeah, one page. Okay, that's in the realm of expected. Let's add that. Amend the previous one. Okay. Now, so we've done the client side of this. We have not done the server side. It is a little bit more, I don't know, we need to think about it a bit more. We molded over a bit earlier. Right. Oh, and I forgot to, let's see, Grudy, thank you for the follow, and Dramix AI, thank you. So this piece we just implemented. This piece has yet to be implemented, or at least for this function, this request. Let's go find the code and stare at it. What does data plane do? Oh, great question. So data plane is what we're using in order to send data from the machine that's writing changes to the database to the machines that are reading data from the databases. So when a request comes in from the internet, the request will get directed by the proxy server that I've written to either the mutation server or a non-mutation server. So the mutation server would track the changes that are happening to the SQLite database, and data plane would send that change to data archive. It's meant to be super light, very, very light, as light as I could get it, because I want to squeeze out every ounce from this machine. Right. Readers, sure. Spin up a bunch of them, but a bit of a choke point is our writer. So here we shuffle the data off onto data archive, which then fans it out to all of the other machines that need it. And Limbox, thank you for the follow. I appreciate that. And welcome. Please feel free to ask questions. Let's go into data archive. We want to be in replicate. I am not rewriting SQLite in Rust. Yeah, no, that's some other project. It looks really, really cool, but this project is completely separate. This project is more like, I don't know if you've seen it, but Fly.io has LiteFS, distributed SQLite. Wow, that's bright. How do I change to dark mode? Do they just not have it here? Anyhow. But essentially what I'm building is a more performant version of LiteFS. LiteFS uses a fuse-based file system and can only track so much so quickly. It shows that as it did not have to use a VFS plugin. And if you remember in my implementation, I use a VFS plugin for SQLite. So I'm in the writing pipeline inside of SQLite. So as the application makes a query to update a page, I see which pages are getting updated and tell the data plane about that. Okay. Very similar to what LightFS is doing, except I'm hoping that mine is just that much more performant. I want this to be very, very, very scalable right off the bat, because I want to be able to write some kind of more or less commodity websites that people could use and I could host at a dirt cheap rate. Imagine having like WordPress that doesn't milk you for $100 every month. So that, and I want to be able to host any application as long as it can load a VFS plugin. All right, where to? Stream database updates. Here we are, the dummy implementation. Yes, it works with SQLite. So, for example, that game that you've been investigating and playing with. Sorry, I was looking for the name. Swords of the Stars 2. Yep. So Swords of the Stars 2. Imagine that you could tell it to, load this VFS plugin, and it would replicate the data to a bunch of other machines as you're playing. It makes more sense if it's like a web server software, but you could use it for anything that uses SQLite. All right, so for this one, goodness, what do we do? Let's make some notes first. Why is it talking about pin? That is so distracting. All right, so at this point, what is the content of that function going to be? We need to do some basic things. Given the starting point, fetch all pages from the DB and send them to the client. I think we should probably have some epic buffer here. After sending all pages, all requested pages, from the ring buffer. Epic blarg. Great question. This is a single writer replication or single master replication. This is not multi-master replication. However, I was considering that, let's close that, that the proxy and cluster management could know which files are being requested, right? So as an application was scaling up, right, the writer machine could be, big beefy machine that ends up fanning out the data to a bunch of lighter readers. Right? Okay. However, if you needed to split up the information even more, right, I had something in here called shard. Was it shard or app But that could be some multi-part key, right? That maybe we end up with different writers based on the shards. Okay. So you can start to break down the readers and writers even more. That's kind of where I'm leaning with this. Even though it's kind of a single writer, I'm looking to have more than one writer for different portions of an application. Right? If you can split off a portion of the application, why not? And it would basically be split down to the point of individual files, SQLite files. Back to the code. Ah, sarcastic Dante. That where is that code? Um, this here is telling RS test to await the future, so I don't have to. Yeah. So this here, this 3DB test context is a, what is it? It's a fixture, but it's async, and that tells it to await. Yeah, it was a suggestion. We've been playing around with it. It's actually made the tests for the server and the client much nicer. So given the starting checkpoint, fetch all pages from the DB and send them to the client. Fetch all pages. Checksum. It's a checksum. Fetch checksum pages from the database and send them to the client. After sending pages to the client, stream any new pages from the ring buffer. If there were too many, let's see if the ring buffer no longer has the pages. Something like that. Unbounded channel. Good. Expected unbounded receiver stream. Did I? Ah, here. So what does this look like? Let's look at the README. Data archive README. Okay. This is basically our database schema. It's in this file. Where is it? Here. So given a checksum, we will map that to a transaction ID. And we would ask it for that to, there, or to basically with no end range. Just give us all of them for all of the pages. Oh, interesting. Because these are by page. Would we do it that way first? No, we would do this. So we would start here and just start sending these because we need the database to be in a consistent state after each transaction is sent. So we can't use this information directly and skip pages that have been basically duplicated. But if we keep updating page 5, 5, 5, 5, 5, right? Previously, we would just get the most recent version of 5, but we don't want that. We want all versions of 5. So for a given database, starting transaction, we just go from here to the end, and getting all page numbers, all transactions. We would need to remember where we left off in case we had to come back and do this again. Yeah, I think this machine just might have a lot of memory. The archive server. Basically, we need so much data for fast-moving databases. We'll have to finesse that as we go on. Oh, or, or we could use something fun. Let's see. I want to use. Oh, what is it? It's a Rust-based alternative to Kafka. Um, what is it called? No. Is it Fluvio? It might be Fluvio. I think it's Fluvio. Wow. Okay. No, I don't think it's Fluvio. It's not. Hold on, let me check. Where's my Discord? Discord, where are you? Iggy. It's Iggy. The great thing is, Iggy is incredibly fast. It doesn't do some things, right? Let's see. Do they have information on their blog? Also, night mode, please. Technology radar and current goals. Okay. Well, replication. Okay. Current goals, replication. Replication does not exist there. Now, do I need replication? Well, if you remember, in my design here, I'm getting replication and data stored in TiKV and possibly S3. So do I need replication for this? No. So I think I would be okay using it now without replication. Basically, Iggy could replace the ring buffer that I was talking about. If Iggy blows up and starts again, who cares? And you just load data from TiKV and then whatever's available in Iggy. Yep. Lots of data in S3 as well. Yes. In order to read your data, you have to download it from and restart your server. If only for stuff that's in S3. That's fine. I don't think we need that right now. You can think of the following analogy to different kinds of cache storage in your PC. L1, directly available, RAM, super fast. L2, data stored on your server disks, still very, very fast with NVMe, SSD, blah, 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 right? And this is mainly where we'll be using it. Open telemetry. So how would we do this using Iggy? Because Iggy's doing essentially what I want for this streaming portion of Data Archive. Data Archive is really just going to um, coordinate, right? It gets data plane information from the storage cluster. So when a machine starts up, it can download a database. When a machine starts up, it can sync a database. But when it starts to stream a database, the data will come out of here. Data Archive will toss it into Iggy. Toss it into the storage cluster, and then send it through. Now, question though. Question is, does Data Archive hide the Iggy interface? What if we did that? Let's move this down here. I need more room. Oh, okay. We can just, all right. So we have Iggy. I don't think I want data plane talking directly to Iggy. I want that layer of indirection, which is just enough. And then we can change out the implementation as we need without affecting all of the machines. Actually, it's going to look probably a bit more like Iggy's going to be out here, isn't it? Yeah. I want to manually draw a line. There. Okay. I need to use events. Spellcruncher. I lost the train on that one. Um, I think with Iggy, and we're going to use this. Let's see. See, I'm going to convince myself that I want to use Iggy. Not the best way to be, objective. Hmm. It allows creating streams, topics, partitions, segments, and send receive messages to or from. Stored on disk as an append-only log, and are persisted between restarts. Great. Highly performant. That's what I want. I want it to be cheap. That's the other end of cheap. Highly performant. High throughput. Low latency. Predictable resource usage. Configurable server features, caching, segment size, data flash interval. Nice. Possibility of storing the consumer offset on the server. I don't think we need that. Multiple way of polling the messages by offset using indices, timestamp, first, last, end messages, the end message for the specific consumer. Interesting. Okay, we'll have to reason through this. We will know about what time we're talking, because part of our key information is the epoch. Message expiry. That could be useful. Where do we really want to store our data? I think it's TiKV with S3, but not Iggy. Iggy's our stream. Optional data backup and archives. Okay. Open telemetry. Yay. Oh, I love that. Single binary deployment. So easy. Okay. Architecture, message streaming. MQ is a message broker, which means that it's responsible for delivering the messages to the consumers. It works in a FIFO manner. Okay. If you have multiple distinct consumers, each would create its own queue. Okay. Once the message is processed, it's gone from the queue. You see. Kafka, it's a streaming platform. It's not responsible for delivering the messages, but rather for storing them in a form of append-only log. Consumers are responsible for reading the messages from the log and processing them. Sounds familiar. Where's my water? Consumers can read the messages from the beginning or from the specific offset. Yep. A typical message streaming platform follows the so-called dumb pipes and smart endpoints pattern. I hadn't heard it called that before. All right. Ziggy's the ladder. Fine. Append only log. Topic. I wonder, would we use database names as a topic? You know, shard plus DB name. Let's see. Well, we could put an equal sign between the log and the stream. They are not the same. Stream is a logical concept. You might think of it as a namespace. Okay. Oh, and Violers, thank you for the follow. You could have a single stream for the whole system or multiple streams representing different environments. The stream is identified by its unique ID, so maybe shard. Stream can have one or more topics assigned to it. Topic, maybe this is the database. Topic is identified by its unique ID. The important thing to note is that the messages are not being stored in the topic directly, but rather in the partitions, which are assigned to the topics. The topic can have one or more partition assigned. Topic can have a retention policy assigned. Okay. And the partition has its own unique ID and belongs to the topic. Okay, yes. Partition is identified by its unique ID, which is an integer. Hmm. Sumer groups. Hmm. Interesting. Segment structure. All right, getting started. Well, I'm gonna have to implement an IGI interface for testing. I wonder if Sled could do this as well. It sounds like it. Setting up the project. Okay. Building the producer. Connect with the client. Okay. Log in. Not sure how I want to do the partitioning. All right. But I think we should use Iggy. Batch size, interesting. I think it's going to be fairly chatty for us. We'll probably have it set to like 1 millisecond. Our batch size pretty small. That'll hurt throughput, but we'll see. We want the clients updated as quickly as possible. I'm sure we'll make that tunable. All right. So for now, I like the idea of Iggy being there. Definitely use that. Oh, this is rather sparse. No login credentials. Okay, client. All right, well, let's see where we go. Data archive. What was it? Partitions. Um, Stream topic. However, we're going to hide it all behind an interface. And we will let future self handle that. Because we are not going to implement that at the moment. Coming back to replicate. There's no ring buffer anymore. From Iggy. If Iggy no longer has the pages, go to 1. Looks good. Well, I'm going to take a moment, pour some tea. Chat amongst yourselves, huh? Later today, I have to go work in the shop again. Got too much junk in there. You know, bags of concrete need to be moved around. Gonna pour a sarsaparilla. Oh, yeah. Yeah, I really like the idea of having Iggy. What do we want to call that? The interface between, like, see, we have DB as our interface between the server, data archive, and TiKV or SLED, right? Because we actually use SLED for testing. It's much, uh, it's just easier because we don't have to set up a TiKV cluster to do our local testing. It does actually make the tests faster, easier to iterate, etc. I'm going to look for inspiration here. Streaming platform, we could call it SP. Yeah, I like SP. That was quick. I was not expecting that to go so quickly. So we have our archive, we have our streaming platform. Looks like we want clone for that. Why? I don't know. All right. So in this case, it uses archive. What do we have for data archive? Data archive. I want to kick archive out of lib. We have storage. Storage implements our storage trait. Archive uses stuff in storage. So maybe archive moves into storage archive? I kind of want to rename storage as DB and then have SP for a streaming platform. DB SP. Total Eclipse, thank you for the follow. Okay, we're going to do a little bit of bike shedding here for a little bit. Yak shaving. I get them confused. I think it's bike shedding because we're improving the bike shed. Can we go here? I want to see if this will. So if we rename storage here, let's kill that. While it's thinking, it didn't change it. Why did you not change it? Oh, well, it did. Okay, but not this file. Let's try again. Data archive, lib. Should have most of that renamed. Archive, I want to move. Archive is just sitting here. It has get, it has set, it has some higher level functions on top of that. I've been thinking about removing some of these. Get database state. Could it just not do this? Database info, same thing. It's passing everything through. And it's only used by the tests. Well, let's just do that. Why is there the both? We're unwrapping and DB state key. What does that give us back? Oh, an option. Okay. A result to an option. And this is our test code, so we are unwrapping. However, it should just be boxed. A boxed error. Oh, nice, dude. Always the bike shed and never the bike. Oh, so true. So true. All right. However, the point of that was to get rid of this function on set database info. No, I don't want to rename it. I want to get references. See, same thing. We have our key, we have our value. Wait. Set database info. We need our page size set. 4K. It's so much easier to just type 4096. Let's make sure that this still works. Well, it compiles, right? Not yet. Oh, this didn't. Oh, it didn't rename storage. Yep, same here. All right. We don't yet have SP, but that's okay. Just trying to make sure the rest of the changes didn't break anything. The trait bound is not. Trait reverb data archive is not implemented for replicate server. Oh, yeah. Okay. That's because replicate down here is also having issues. Hmm. Oh, it did. It did have a get database state and a get database info. This did not show up on the search, on the reference search. Probably because I broke this file ahead of that. Database state, that's not what I want. We want this. Database scan key or database state key. Okay, let's go back. Yeah, this is, feels like database scan key. Oh, it is database state key with a shard and a name. Oh, of course. I was looking at data thinking this is the page data, but it's not. Okay. Ah, we are not awaiting. We want the future to await. Okay. And what kind of feature is this? Returns an option to a database state key value. Okay. So in this case, him. We're expecting options below. Good. Hmm. Database info. It's database info key. We haven't gotten rid of it yet. There it is. Okay. Okay. Let's go back to archive, which is here. Let's make this go away. Type annotations. Ah, one more. The Iron Flame. Thank you for the follow. Oh, Kojo. Kojo Oklama. Well, thank you for the compliment. This is early in the morning before I go inside and get all shrill. Database state key. There we go. What other errors are there? Okay. Doesn't implement clone. That'll surprise me later. Right there. Run the test code. Everything will fail. Won't understand it. Huh. Look forward to next time with to-dos. All right, replicate. And we don't have the other type passed in yet. So new, it needs a DB, it needs an SP. Oh, I guess I could have just pushed that back. And why didn't I call it SP? This we called archive because it's an archive type. Oh, it's because we don't have a streaming type, a streaming interface yet. So now we have DB. Let's create a new module. Make dir source. Oh. What do we want to call this? Streaming? Stream? SP? Yeah. Okay, let's do that. Let's make a new file. Write that as data archive source sp mod.rs. Trait. Streaming. That's kind of verbose. I called the other one storage. Back to lib. Okay, archive's fine. Good. Like streaming better. There. And we definitely want some interface around it that takes some sort of type of struct. Archive was nice because we're storing data, right? Oh, this interface and wrapper. Hmm. It has some nice utility functions, right? Get, set. Arguably, these could have been put on the trait as default functions. And as you can see, I was getting rid of all of these. Right? There are some actual useful pieces. Set database page. It's using functions basically that are more or less on itself. So why are these not on the trait itself? Huh. All right, light bulb moment. Why don't we get rid of archive? Instead of finding something to wrap SP with, let's just move the information that's in archive into DB. And DB implements storage. So essentially, we would just move some implemented functions here. As you can see, there is a get, right? There's a set, or get a put. Oh, there might be a name conflict. Hmm. What's another word for getting something out of a database? This is a higher level set, right? It does take a little bit more information. I think I would change the other one to raw. Hmm. Up here. These are the low level interface functions. And the other ones that I want to bring in here are higher level. You know what? Maybe it should be a trait, but it's not storage. It's a trait that takes another trait. Pub trait. Um, let's pretend that there's high level and low level. SKRY? Hmm. This could, oh, for the moment, implement something like that. And then we have these higher level bits. They're implemented against that, and they're just traits, functions that sit on top of that. All right, I'm going to rename a bunch of stuff. Let's get rid of that for a moment. Come back. Context What do you want? Yes, okay, fine. That's okay. But storage. I want some inspiration here. Raw? What about low level? Low level. Hmm. Let's rename that. At least so it's not sitting on that name. Let's say we have storage and raw storage. That's not missing though. Oh, it just didn't save. Okay. So we have our raw storage. It does not need to be public. Ooh, this is going to be interesting. Okay, let's just make that like so. And then storage, we'll do all the fancy stuff on top of raw storage. Back here, this is basically what archive was. I'm taking get and set. But what is storage though? Sure, it's an associated type, but it's not a thing that's on a that we can use. It's not on self. We could have function. Something like that. And then this still has to implement it. But it's hidden, at least behind a raw storage interface. Not so bad. I don't know that I want to be that prescriptive. That's right. Now we have error, which is a bit of a raw error. And we have our higher level error. I don't know. What do you guys think about this? Building a little bit of a facade in front of our raw storage API. Some higher level interfaces, right? Get, set, with kind of more information included in the key. I like that it has an escape hatch. Raw storage is still there. We do things like deserialization for you. Serialization. Rename this. Raw storage error. Let's go to here. We're taking that. You know what? Let's go a little further. Mod raw. There we go. This is going to break everything. We have DB, then raw, then storage. Then we have DB, then storage. So we have raw storage, and we have storage. Yep, okay, doing it. Here we go. Extract that to a file. Take that, go to the top. Toss that in the module. Rename this back to just error. That needs to be pub. All right. Fix this up. Compare and swap error needs to be here as well. We're not really using these. Everything exists there. Let's fix everything, then we'll just inline it. Oops. All right. It is no longer raw storage error. However, it is raw storage error, or just error, raw error. Well, that should already be there. Okay. Now that we have that, we'll rename this to just be error. Fixes some things, not all things. Okay. Let's go back to mod. No. Raw. That looks good. Sled. How are you? Ah. Oh, it is called raw storage, but it's not. And let's make it just raw. Sorry, just storage instead of the raw module. Go back to sled. Now that works. Okay, this file works. TiKV. Done. Okay. Ooh, DB keys. What do we have here? I think DB keys should be in the DB module, just called keys. Data archive, source DB keys to data archive, source DB keys.rs. I do not believe that everything is just magically working. Data archive mod. Okay, data. Huh. What else is broken? Let's see. These are coming from the types. Database state. It's right there. Oh, does it not like this? There we go. Which error does this get? I think it's a storage error at this point. Technically is super. It's a DB error. We're down to storage, and we're going to move some of that. Those are all of the errors in storage. Main. Oh, our test context. All right. Self to archive dot get. What is self.archive? That's archive object, when in reality it could just be something that impulls storage, such as sled storage. We'll just make it work for now. Well, no, I'm not going to fix that one. Anything else? 3 there. It's okay. Replicate. Don't capitalize everything. Okay. Hey, Sim. Oh, the color theme. This is called Challenger Deep. It even has a website. And get it before someone puts it behind a paywall. Oh, that's funny. All right. So, there's lots of issues here, but that's fine. Expecting that. We could do something like new archive. And then we have, sure, DB. Why not? Simple. And this is DB storage for new archive. Hmm. Interesting. This isn't a concrete type. This is an interface. I would not use the associated trait type. I would just have something like so that returned whatever the raw storage type was. I guess we could do this like so, DB. I need to change that to be a reference. Wait. The Theo video? Material theme drama? Goodness. Hey, hey, Lumi. Lumi Code. How are you? I feel like I haven't been hydrating well. I'm good. I'm good. I have the week off, so nice and relaxed. Next week, gotta get back to it. So, longer streams this week. I'm shorter than on. Um, helped some friends move yesterday. That was fun. Now, most of this stuff, like get database, that could move. Set database state doesn't need to exist. It's basically that, wherever the caller is. Yep, test context. Of course, usual offender. DB name is deleted. Checksum is DB checksum. Oops. And transaction ID already exists. Great. What is DB? Sled storage. That's not what I want. And I moved it off of that. Well, I think it's correct at the moment. I'm going to leave the errors and come back to them. All right, 2 more callers. Oh, need to go back a moment. No, no. Where were we? Too far. 715209. How are you? What is a stir? We don't need a double borrow. Checksum. State.checksum. Transaction ID. You know, I would rather. See, database state key returns a. Oh, where was it? It's at the top of the file, isn't it? Database state. Go figure. Oh, do that again. There we go. Now we do not want that. We want the new is deleted. Oh, you know what? We can just elide the rest. Okay. One more. Let's see. Grab that. Database state key, database state value. What is checksum? Checksum is end DB checksum. And transaction ID passes through. Okay. Oops. One line too many. Hmm. Get database info at checksum. Funny. I think I've broken just about every one of those places. And if there is an error here, we want this. Yep, something like that. Set database page, get database page. All right. This one here also needs to go away. Database page key. Page data equals to that. Shard, DB name, page number, transaction ID. That all looks good. Except, was it? It does await, but it doesn't process the error. Okay, good. Page transaction ID. All right. Good. Now we can take the rest of this, get rid of that. The rest of this actually goes onto the new trait. Oops, one too many. Now let's fix these up. Lots of imports needed. Self.raw storage. Good. Did we not use raw storage? There we go. Raw in the previous one. Hmm. I wonder what that's referring to. It's not found for this. Implements raw storage. Okay, that's an error somewhere else. Let's see. Context. Let's ignore context for just a moment. Replicate. Yes, replicate. Unused value. Most of those are broken. All right. Well, looks like we're back here. We have new archive and we have archive. We could get rid of this and rename this to archive. All right. Storage has set and get. Why is it complaining about that? Two arguments. Don't care. There we go. So we set an element here, bailing. want to do a little bit of a sanity check here. There we're deconstructing, setting, set database page. Just per 89. Thank you for the follow. Set. I think we've looped. Yeah. Oh, is deleted false. Ah, yes. It was being used there. So far, so good. Okay. I want to stare at this for a moment. Archive, we extracted everything out of it into the trait. What did that exercise buy us? We've hidden raw storage. I like that. Raw storage is hidden just a wee bit. We have done that without the trait? Yes, we could. Our little facade here. I guess we could impl this for our tests, and then we could override some of the functions. Hey, Mr. Philbs? Mr. Philbs. Oh, sure. It's not quite Rust related, but I'll take a stab at it. Question here, because I don't have chat on the screen. What is the best method for storing pictures for a web app? So, couple questions. Do the pictures change very often? The reason I ask is because if they do not change very often, then it makes sense to store them, or at least have a CDN in front of where you store them. Users will upload photos for a post and can't be changed after. Is it important for the image loading to be quick, right? Should the data be close to users where they connect to the internet? If that's not important, then it's maybe don't use a CDN. But generally, you can see that the questions are really related to should you use a CDN or not. It's less about where you store them. You could store them on, let's say, S3, right? Some S3 capable endpoint. It could be the Cloudflare, what is it, R2, or AWS's S3, or just some cheap storage that needs to just have the data so that a CDN can load it when it needs. It's kind of a combination there. If you're just building out something small, right? I would probably still use something like an S3. There's lots of these. S3 itself, right? R2. And if you do use the Cloudflare one, it's called R2. Sorry for the blinding white Cloudflare page. Um, but essentially, they have the same S3 compatible object storage APIs. Um, so if you don't like them later, you can go elsewhere. But they also happen to be a CDN. So, oh, another question. Do you need to protect the content, right? Or is it something where people that have the link can just share the link and access the image? Because if you're doing like a file sharing, image sharing site, then you'll likely want to um, use the S3 APIs that generate a link that expires. Okay, so sharing is encouraged. Send me Facebook, Marketplace app. Okay, gotcha. Um, is it okay if people use the image on their own website? Let's say they upload it to yours, you pay for storage, you pay for traffic, and they put it on their website. Yep, and Rockerboo's right on there. Storage can be separate from a CDN if you do a lot of distribution, which is kind of where the questioning is going at the moment. Yeah. Basically, S3 gives you, or the S3 APIs give you everything you need to protect your content, to deliver your content. Lets you put CDNs in front of them if you want. Lumicode. You'd personally use either a local storage, same as web server, or hot object storage. And that has benefits too, right? I mean, the benefits there are what you don't pay for the extra bits, right? The extra service, it simplifies your infrastructure a little bit. But it does, like, depending on your scale, it can, uploading can starve your resources. Um, but I've done that exact pattern just so many times, probably hundreds of times. And as Lumicode pointed out, right, storing it locally, that works really well too. Um, and the Amazon S3 API has been basically commoditized. It's everywhere. Um, if you want to use it, find a service that supports it and just run with it. S3 the protocol. They just have the service of the same name. Oh, that's funny. Yeah, Mr. Phillips. You're welcome. Going to move this. It should be in DB mod now. Storage. We have all these impls. Let's put our new thing at the top. How about here? Oh yes, Minio is. I've actually used Minio. That's great too. Yeah, as an older engineer, oh, let's say seasoned, as a seasoned engineer, um, I would direct people to not modifying the file system of the system that they're running with user content, right? Which is why I tend to lean towards pointing people to APIs on services where they're not going to run into the vulnerabilities that are possible. Right? If somebody says, I want to upload my file name or my file, and the name is slash user or slash etsy slash password, right? And somehow they're able to, maybe via a bunch of relative file system, whatever, mumbo jumbo, they're able to overwrite your password file. And you can, like, bad things can happen, right? So if you're just getting into it, that's why I lean towards having those other systems in place. Use like an S3 compatible thing. Oh my goodness. Oh, Rockerbo. Oh, that's painful. One of the company you were at did that with a 777 permission. Yeah. Pouring some more tea. Last little remnants. Last cupful. All right. Okay. So we now have this archive thing that we call storage. Hmm. Or this storage thing that we call archive. I think that's more accurate. Yeah, you have stuff in data center. Oh man, I don't have stuff in data centers anymore. I miss it. I would rather have stuff in data centers. If I could get fiber here, I would set up my own rack here. Join you. Ah, I think this all works. Self.archive. Huh. Oh, no, no, no. It's all good. All good. What happened to Zed? Oh, goodness. Somebody pointed out that I wasn't using the AI stuff, that I had turned it all off. So I went back to Helix. Oh, I'm in the Pacific Northwest in the United States. Lived in Europe. It was fun. Feels like a lifetime ago. Get databases. Yeah, that's gone now. Okay, we're starting to get some other things happening. Oh, we're not using storage. Where is storage? Source. This isn't replicate. It is create. Oh, I haven't heard of digital reality. Curious. Whoa. Hmm. Nice. See, and I went away from this. Uh, do we want to use future instead? Okay, those are just warnings. We'll come back to the warnings after the errors are done. You know what? At the moment, I kind of want streaming to not be in that. I want this refactoring to be um, tested before I go on. Oh, buffering more and more. Interesting. Yeah, it looks like the network dropped for a moment. Oh, my internet is junk at the moment. Wow. Oh, somebody's downloading at like 200 megabit per second right now. Which messes up me streaming. It does. Let's see. Who is it though? Hmm. Yeah. Well, let's see. Is it coming back? No. I'm trying to put the priority of my machines higher on the network. But I have to figure out which machine I have. I have not named a whole bunch of them. I think it's this one. Is it just called MacBook Pro? I can't tell. We'll just work in silence. I'm still dropping so many frames. Hmm. I wonder which one it is. It says it found DB error. And this function returns error. Oh, is this the other kind? Database snafu. Database error. Should this be raw? Hmm. Okay. You just got to the music stopping on your end? Oh my goodness. Okay. It works. Let's give it a test. Oh, wow. Really? Data archive. 12 passed. Okay. I like it. Did that as well. Oh, I'm trying not to use up any additional bandwidth. I can see that we just nearly hit 300 megabit per second here, which is extraordinary for us. Okay. But that actually worked. Wow, that was a big refactoring. We have this new archive thing with raw archive behind it. We can implement pieces here.